Good day. My name is Bakadicina, Advanced Diploma student, University of South Africa. Um, I will be sharing here my design for transportation engineering, pavement and geometric design, which has been done in fulfillment of requirement for um, to actually meet GA for transportation engineering. In fact, here I will be sharing more of the practical side, which linked to the theory done of a design that has been for an existing road which needed a little bit of upgrade. So we move from 2 lane to 4 lanes, and also we look at the future of how the road uh, may be more useful in the area that it is. So without overdue, I would love to emphasize that this PowerPoint presentation is just an highlight, and the report details will be placed in the description below, as it will be submitted for marking to the lecturer. Thank you. In fact, in terms of reference, we need to more comprehend that the scope of work here was mostly the pavement design, geometric design. Why pavement design? Why geometric design? We need to understand that a road is not just what we see, it's actually every fundamental, or particularly the geometry of it, and also about the material, and without forgetting also other things that come into play when you are talking about drawing a road, as I wanted to say. The general description is the road taken for this project actually has chosen the provincial road, the P515, which is a rural road in the west of KwaZulu-Natal, in the Empangeni region. So it's more of a coastal road. We understand that Richard Bay and Empangeni are a little bit along the coast. So it's a road that is coastal, approximately 30 kilometers northeast from Richard Bay, Central Business District. So this road is of a very, it's very important, as it's linking numbers of villages in the region. And by road, we know that it's a communication tool. And as it is a communication tool, what it does is linking the two villages, a couple of villages, I mean, it basically means that this particular road plays a very important role in the life in the daily activities of these particular villages, which means the goods that need to come in the villages, the things that need to go out of the villages. We have some farms around and all those kind of things. So this is a very important road, which actually this upgrade is needed, as also there is expansion of the population, and also there is a little bit of development that are taking place in the area. Though the upgrade is actually a very important fact. So the root function, as you can see here, it's category C. However, it's better to understand that as the project brief, we were asked to go with it to category B. So the road that is category C is low in volume, right? I'm not saying that the fact that this road is low in volume, it means it's not of high importance. It's high of important, as it's linking a lot of villages, and it's one way of communication within the villages, and also moving goods from one village to another, from the villages to the CBDs, and from things from the CBDs to the village. So the growth can be rapid, and unpredictable, and also based on design reliability plus or minus 80%, which is actually means that half of the pavement distress at the end of the design. So while trying to develop this very road, there are a couple of things that we had to go into. And the most important thing also was the physiography of this particular region. And by physiography, I went through into talking about the climate. Why is it important? The climate is very important, as we know that in engineering, every material that we use is deemed to certain temperature conditions or certain it can behave differently from one area to another, depending on the climate, the change of climate, which act on the material, and the material which will actually determine the lifespan of a particular structure. So in terms of climate classification, we actually may understand that this particular road is actually placed in a wet region. We need to understand that wet region implies a lot of things when it comes to the design of a particular road. The Mpange region is a region in South Africa with significant amount of rainfall when it comes to its mean. We spoke about climate, now we go into rainfall. Mpange region is where we have a significant amount of rainfall. At the beginning, we need to first to understand that South Africa is a semi-arid country, and when we are speaking about a semi-arid country, but we know that the amount of rain that falls on the ground is actually a little bit less than the amount of water that we need within South Africa. Now, you are going to realize that this particular region is very particular in terms of the amount of rain that actually fall on this ground. We can realize this is it's the highest is in January, and that is during summer. We can realize that between April and October, the region receives minimum amount of rain. So that is basically before the beginning of winter and at the end of winter or beginning of summer or autumn. We are going to realize that during that period, we have a limited amount of rainfall, but during summer or summer period, the rain is actually very heavy in the region. In terms of temperature, the temperature are highest in average between January and March, which is actually during summer. The average being 25 degrees, isn't it? And besides the 25 degrees in average, when we get the minimum here, it's generally 15 degrees Celsius to a maximum of 16 degrees Celsius. So the coldest month means that the construction program may be affected for activities like sealing of pavement. We know that when we are actually sealing of pavement, we need to work on very high temperature, so we can do the rest of works during this period, and as we do not have rain between starting of April and moving forward then, but the rest of work can actually the sealing can actually be happening in summer. So all of this, knowing about the temperature, will actually give us an advantage in terms of when to actually start with our foundations or to do the groundwork and everything. Then when it comes to the sealing of the road, we actually will be doing well if we do it in summer. So with an average temperature of 25 degrees, it can be better depending on the type of asphalt that we are actually going to be using. After the temperature or this physiological aspect, we need to have a look at the traffic loading design. And by traffic loading design, we actually going to speak about the traffic data. It's very important to understand that for practice purposes, some of the information that we have used for our traffic load data, we collected them from sources that are not that gave us data which are a little bit have been it have been a long time that's the data we used, but we mainly focus very much on practice part of it, which means some of the data that we have utilized here are actually estimated, but those estimated are almost what we need actually to do. Something in particular that we need to highlight here is to actually remember that the traffic, isn't it, load data was required to calculate for the future loading, isn't it? The main road, which is, sorry for that mistake, it's road 515, P515 from 6 kilometers to 17 kilometers. So in pavement design structure, we use a couple of standards, and amongst the standard we have the South African pavement engineering, the South African Pavement Engineering Manual, second edition, published in 2014. We use the TR H4 1996, TRH14, TRH17, TRH20, and TRH26, which were the standard used into our design. We consulted them to actually, and to that we also add the South African National Road Geometric Design Guideline Manual, which is SANRAL GDG manual. So minimum subgrade strength and in situ delineation has per the PR H4 1996, the major reason of the design process is the protection, the use and improvement of the bearing capacity of the in situ subgrade material, so that the pavement will be able to fulfill the service objective over analyzed period. So road capacity, we had 10%, which is area of length of the road exceeding terminal conditions, TR10 table 1, approximately design reliability, which is TRH4 table, so on and so forth. It is also important to realize that most of these calculations were done with a design speed of 60 degrees, which we had to start to find our PA and then PI1 start, PI1 to start, delta y and delta x. We had to calculate also the direction and the distances, PI, calculate the curves, because this road is quite long, and as it's long, we have curves here and there. We also realized that after our calculation that we had normally had to use V drainage, and after that we need to, after doing all calculations as we had to do the drawings, we decided to use Civil 3D, which gave us a little bit of trouble because we had a little bit of problem of moving moving certain information from Google Earth to send them to Civil 3D, but in all everything actually worked well. As we can see here, we were dealing with the meso diagram, how we could cut and fill, but we actually realized that the imported material, we had to import less material, but the rest of material were the one that we're cutting this side were the one that we're using on the other side. So as we can see here, it's just an alignment, and we have also a secondary road that moves as we indicated that this particular area is linking a couple of villages, and that will tend to give us a little bit of work and the importance of this very particular road. I guess this information will be important to actually understand, but I insist that most of the calculations has been done and reported, and then the report will be given down below. Thank you very much.